Okay, cool. So yesterday we made it through quite a bit of the paper, but I'll give just a bit of a recap. This is the paper we're reading. It's called Consciousness and Inward Electromagnetic Field Interactions by M. Bruce McIver. So it's a pretty interesting paper so far. It's essentially an experiment that they've been running. We haven't gotten too much. We've just dipped our toes into the experiment. Most of the paper so far has been an exploration or explanation of how the electromagnetic field theory or theories of mind and brain integration have been viewed by the public in the past, over the past 70 years, what they are, what causes this electromagnetic field. Um, he mentions that the electromagnetic fields are obviously being produced. Yeah, there's no doubt that this energy cloud exists since it's easily measured using both electrical and magnetic detectors. So he's showed us, you know, how they form due to synaptic and discharge currents in neurons, what they look like. You can see figure one. You can take a look at figure one. So these currents are caused by the electrical um, discharges in neurons as well as the ephaptic. This diagram here, 1A, actually shows how ephaptic uh, connections work. So you can see this neuron on the left is creating a current, which is in turn affecting the electromagnetic field of the neuron on the right, which in turn affects its current. So the neurons generate the field, and the field affects neurons. So it's kind of a loop. And then this aura like rendering here shows the electromagnetic fields. This is most likely feels AI generated, but um, it's I think it's a good figure to evoke this feeling that he's trying to evoke in us, right? On the left, you can see he's trying to say, okay, these are circuits of connected neurons, right? These are like, you know, real life circuits, right? It's like logic gates, essentially. Neuron A activates, it's connected to neuron B and C, and then goes on mad. These neuron to neuron signaling creates these systems which supposedly generate the consciousness, but not in his theory. His theory is that signaling, that electromagnetic activity, actually generates an electromagnetic field, which you can see here and 1C on the right, which is this aura like field. And he's saying essentially that consciousness, our unified conscious experience, isn't in the circuitry signaling, but it's actually in or held by the electromagnetic field itself. Perfect. So, yeah, the other big kind of point that he was making at the end of the reading yesterday was A lot of experiments had been done to disprove the electromagnetic field theory over the past 70 years. So the theory states that the conscious human experience exists in the field. So, and mind you, this theory is not currently the most widely accepted. It's more of an underdog theory because it has been entrenched in a lot of pseudoscience. So this author is trying to make the point that a lot of the reasons why the electromagnetic field theory were dismissed need to be revised. It shouldn't be thrown out. So that's mostly why this paper exists, and also there's an experiment that we've just dipped our toes into. But some of the experiments that quote unquote disproved the electromagnetic field theory of consciousness said that if you block, why do not EMF shields or perturbations of the EMF affect mental processes? Essentially saying, if we're blocking or short circuiting the electromagnetic field, why aren't they affecting our mental processes if our consciousness is that field or is held by that field? So you can see here, short circuiting or shunting the electrical current flow experiments have failed to show altered mental processes. And interestingly, these papers are from 1951, 1955. This one from 2022, but yeah. Cool. So his rebuttal to this is that these all these experiments were taking place essentially on the outer layer of the brain. And he's saying since synaptic currents always take the path of least resistance, the EMF will actually extend further into the brain rather than outward due to increased resistance of our skull tissue. So he's saying if the mind is located in these centralized overlapping EMFs, it provides a stronger possibility of unification, binding of very divergent brain activities into a central whole. And we can see that in figure 2, like we were saying, that the outward fields would play only a small role in modifying neuronal activity. This is critical because we know that EMFs influence the discharge of neurons, and this closes a loop for mind-brain duality by linking EMF energy back to controlling neuronal discharge. So before we get to this one, I just want to talk about this. Essentially, he's kind of minimizing he's trying to rebut that those experiments previously done in 1955, 1951 that we mentioned, where they short-circuited or shunted EMF, and it didn't alter mental states aren't so relevant because outward fields would only play a small role in modifying neuronal activity. So he's saying maybe if you shunted the activity deep inside the brain, right? Like here, you can see there's so much more overlap and so much more field, less resistance. Maybe if you were able to shield or block the EMF closer to the central parts of the brain, maybe then it will affect mental processes. So he's not saying this is true, but he's saying that it's not necessarily true, but but he is saying that it's not enough to disprove EMF consciousness theory. Now, finally to this one, because this sentence I thought was super duper interesting. So he says, this is critical because we know that EMFs influence the discharge of neurons. Okay, so this is one thing, right? EMFs influence the discharge of neurons. We discussed this before when we were talking about ephaptic connections. So this is when one neuron generates an electric field, generates a current, which affects the field of a nearby neuron that isn't necessarily directly synaptically connected to that neuron, but just the proximity and the strength of the EMF of one neuron can affect the EMF of the other neuron, which thereby affects the current of that neuron. So the field itself is affecting and influencing the neurons. So that's what it's saying there. This closes a loop for mind-brain duality, linking EMF energy back to controlling neuronal discharge. So what I'm taking away from this, and maybe I'm taking away too much, is that it's so interesting because we think of everything from a materialist point of view as being completely deterministic, right? So every little cause and effect dominoed from the beginning of time to planets, stars, gas, biology, DNA, and finally the building of our human brain. But the second the human brain turns on, the second that EMF starts getting generated, that's when we turn on, according to this theory, right? The EMF is our consciousness or holds our consciousness. But once the EMF turns on, the EMF actually has the ability to affect the neurons themselves. So we have this conscious, quote unquote, free will, which is able to affect the biology itself. So once we start getting generated, once our consciousness exists, we're not just controlled by the neurons, the deterministic. We're able to affect and influence our biology and thereby our surroundings. So that's an interesting way of looking at it. The increased and focused density of inward-directed EMFs will provide stronger ephaptic control of neurons. The increased and focused density of inward directed EMFs would provide stronger effective control of neurons, especially those in the brain central regions. So the EMFs that are closer to the center of the brain, where there's less resistance and there's more field, had more influence and control of the neurons. Placing shields or introducing EMFs from external sources outside of the skull would hardly alter inward directed energies and would hence not appreciably alter our brain, mind, or consciousness. This is what has been observed experimentally. So that's a direct call out to Lashley and Sperry in their 1950s experiments that supposedly disproved this theory of consciousness. So that's obviously a direct call out and saying that it's not enough to disprove EMF theory, but it is enough to prove that the EMFs outside the brain, outside the head, don't affect mental states or neurons that much. I just want to talk about this figure real quick, figure 3, because we did talk to chat about it. And it's a bit esoteric looking at it. So we can see there's like 4 different point clouds. So he explained this a little bit earlier. We can take a look. Here we go. This is the main experiment that he actually ran. And he says, I present a new way to visualize these complex patterns using nonlinear dynamic analyses of EEG recordings. 3D plots of phase information derived from EEG signals nicely track levels of consciousness. And actually highlighted this earlier because I was like, what does levels of consciousness mean? But now we know that he's talking about wakefulness, anesthesia, sleep, etc. So that's what these are. These are 3D plots of phase information of different levels of consciousness. So what does that mean? So previously, we took a look at this image. It shows a wave in 3 different phases. You can see the red phase, phase 1, blue phase, phase 2, green phase, phase 3. And essentially, what it means is it's a translation on the x-axis, right? So it's essentially positioning, difference in positioning. That's pretty much it. So when we're looking at the EEGs, he's able to. These EEG waves are three-dimensional waves, right? Your brain is three-dimensional. It's propagating out in 3 dimensions. He's able to see the phase information of these waves in 3 dimensions in order to, and I'm assuming have some sort of arbitrary 0 point in order to plot where they're centralized, or give them some sort of value of positioning within the brain, right? So a wave that originated from here or is positioned here will have a different phase than one that's here, just like that phase 1, phase 2, phase 3 we saw. It's in a different phase. So we can see that while awake, the phase information is this, large point cloud, very spherical, but during loss of consciousness, it's more confined, more and more confined when we go to anesthesia, and it starts to look like a cigar shape, like a cylinder flattened down. And during recovery, of course, it seems to be inflating again. So that's just my analysis of that, but I'm sure we're going to go into that more. So let's just reiterate what we just read. Placing shields or introducing EMFs from external sources outside the skull would hardly alter inward directed energies and would hence not appreciably alter our brain, mind, or consciousness. This is what has been observed experimentally. Similarly, implanted deep brain stimulating electrodes appear to produce two localized perturbation to alter the EMF, the mind's EMF, although effects in cognition do occur in some patients. Okay, so he's mentioning a new study or set of studies where deep brain implants simulating electrodes were supposedly implanted deep into the brain, but appear to produce two localized perturbation to alter the EMF. But the effects do occur in some patients in cognition. So seemingly just implanting like one or two small neuron electrodes into the brain doesn't actually affect it that much, but it seemingly does a little bit to some patients, right? So maybe if they had more electrodes or had a better way to perturb the EMF, right? Or if they perturbed it in a very specific kind of way, right? That we could test this better, right? Because this preliminary test, it almost seems inconclusive because some effects on cognition did occur. Okay, so I just want to get this paper because it's free. So Gloss is going to go and download the paper. And it's also going to read the paper for us so we can get relevant information. Okay, so without opening the paper, we can actually look at the closest passages to the claim. I thought of a good feature where we should be able to just talk to this document. So in the introduction, thalamocortical connectivity has altered in GGE, both structurally and functionally. There's an activation of CM during generalized spike wave discharges as seen in GGE. Modulation of this altered network connectivity may be achieved via CMDBS. Okay. So implanted deep brain electrodes will say it has long been known that high-strength magnetic fields of MRI scanners affect both human and animal subjects, producing dizziness, altered behavioral responses, and cognitive impairment. Oh, that's super interesting. Magnetic field. Of MRIs actually affects your cognition, producing dizziness and behavioral responses. High strength magnetic fields. Weaker EMFs produced by cell phones, radios, and headphones do not appreciably alter mental activity, though long-term exposure to these weak fields may disrupt some brain functions. Well, that's scary. Transcranial magnetic stimulation using strong magnetic pulses are well known to stimulate brain neurons, as does ultrasonic stimulation. ultrasonic. But what is ultrasonic relevant to EMFs? Aren't those two completely separate things? Yeah, I will say a lot of this is good supposed evidence, right? Especially the magnetic fields of MRI scanners affect like cognition. Transcranial stimulation using strong magnetic pulses are well known to stimulate brain activity, as does ultrasonic stimulation. But my question is, let's suppose we take the opposition here, right, and say that EMFs, right, maybe aren't the holder of consciousness. Wouldn't strong magnetic pulses and even strong magnetic fields of MRIs also affect just normal electrical brain activity? Even if the consciousness was in the normal synaptic just discharge activity and not in the field. Like, what if the field is just a field that can be affected to affect the neuronal activity which holds the actual experience? Right? It's like a handle on our experience. So I'm gonna add a note that says strong oppositional, or we'll say skepticism. Entertaining skepticism. With strong magnetic fields also just affect normal brain electrical activity. Even if we weren't in the field. I don't know how to spell skepticism. EMF perturbations on the surface of the brain or outside it, or very close to the surface, do not affect mental processes, whereas EM perturbations that penetrate deeply into the brain do affect mental processes. because that's kind of the summation of what he said, right? He's saying that shielding EMFs on the surface of the brain, like the 1950s experiments, don't alter mental functions. Inputting electrodes deep into the center of the brain sometimes do, but he believes that they're not creating strong enough perturbations. Perturb is such an easy word to say, but perturbations is so weird. He believes they're not saying, they're not creating strong enough perturbations inside the brain, even though sometimes they do affect mental processes. He's also saying that using your phone or radios or headphones don't affect mental activity because of their weak fields, but sometimes long-term exposure does. But super strong magnetic fields, like in an MRI, actually do affect your mental cognition and consciousness to an extent. My question still exists, though. I mean, I intuitively feel he's correct about consciousness living in the field, not in the computation of logic gates, that is, neuronal circuitry. But if you were to be strongly on the neuronal circuitry side, you could say the consciousness, yes, is in the circuitry, and it does generate a field. And yes, the field is a sort of handle, a byproduct that does affect the circuitry, but the consciousness still is in the circuitry, not the field. And high magnetic fields, like an MRI, will affect the field, which will affect the circuitry, which affects our consciousness and cognition. It's just a devil's advocate take. Okay, cool. I think that's a good place to stop for today. We'll get into the rest of this paper either later today or tomorrow. Thanks.